The first one simplifies to -4 times the square root of 2, and the second one simplifies to 27 times the cube root of 3. Nice work if you got both of these correct. Simplifying roots isn't always the easiest, so let's see how we can do it. We can split up the root of 8 into the root of 4 times 2. We can also split up the root of 50 into the root of 25 times 2, and the root of 200 into the root of 100 times 2. This gives us perfect squares, which allows us to take square roots in our next line. Now that we're here, we can take the square root of 4, which equals 2, the square root of 25, which equals 5, and the square root of 100, which equals 10. We multiply the numbers in front of our radicals to get 6 root 2 minus 30 root 2 plus 20 root 2. This leaves us with 6 minus 30 plus 20 times the square root of 2. When we subtract and add these numbers together, we'll get -4 times the square root of 2, our final answer. For our second problem, we want to break up these two numbers into perfect cubes. I know 81 is the same thing as 9 times 9, which is the same thing as 3 times 3 times 3 times 3. I rewrite 81 using 3 cubed times 3. We do this since we know if we have a factor that appears 3 times, we can take it outside of the cube root. So I use my product rule to split up this radical into two pieces, and then we take the cube root of 3 cubed, which just equals 3. For our second radical, we split it up into the cube root of 8 times the cube root of 3. Notice that I've rewritten 8 as 2 to the third power. We do this so we can take the cube root of 2 cubed, which gives us 2. We multiply 7 times 3 to get 21, and we multiply 3 times 2 to get 6. Now we have two radicals that have a matching index and a matching radicand. So this means we can add them together. We'll have 27 times the cube root of 3.